we're going to talk about current in series and parallel circuits. So the first thing, let's look at this circuit. This circuit here is a combination of series and parallel. These two bulbs are in series. Series means one after the other without a choice. There's no breaks in this anywhere. After it goes through these, it goes through this pair here. And these pair are parallel because the current can go through one or the other. And that's basically what parallel means. So before we look at this circuit, you know the formulas. The total current in series is I1, which is equal to I2, which is equal to I3. That means in series, all the currents are the same. When it comes to parallel, each circuit, the currents add up to give you the total. Now what I like to do is basically ignore these equations. What we're going to do is just keep track of the electrons or the current going through the circuit. Think of it as race cars going around a track. We have to keep track of all the cars, and it'll be very easy. We don't have to think in terms of series and parallel. For instance, look at this circuit. I've got 3 amperes in this circuit. Those 3 go down here through here, and I know 2 are going up through this bulb. Well, if 2 go up through this bulb, that leaves 1 to go through here. That accounts for all my current in this circuit. The 2 come around here, and the 1 comes around here. That 2 and that 1 equal 3, so 3 come up here. This source must be 3 amperes. 3 amperes come here, 3 amperes go around this circuit here, they go through this bulb must be 3 amperes. 3 amperes come through there, split 2 this way, 1 that way. It's all very simple. You don't really have to think about series and parallel. For example, look at this circuit. It's a little more complicated. I've got these 3 in parallel. I've got these 2 in parallel because the electricity can go this way or that way. It has a choice. This parallel set here is in series with this parallel set here. So everything goes through there, then it goes through there, and then they all come through here. These ones are in series with this one. So let's start with our 8 here. 8 come out of this bulb, work their way around here. 8 of them must be accounted for. I must account for all my electricity goes through there. The current comes up here. 1 ampere goes that way. 3 amperes goes that way. So that's 4. That leaves 4 left. So this must be 4 amperes coming around here. 4 go this way, 3 go that way, 1 comes that way, I got back up to my 8. So 8 come along here, and I notice 2 go that way. Well, if 2 go that way, then that means this must be 6 amperes. Because 2 go that way, 6 go that way, that's my 8. My 6 come around here, my 2 come around here, they get back together, I'm back up to 8, there's my 8. So I can work my way through the entire circuit just by keeping track of my current. Don't have to really think in terms of series and parallel. The next video we'll talk about voltage in series and parallel.